going to die someday. Sorry to be blunt, but it's true. And when you do, the universe will immediately begin the process of erasing every trace of your physical existence. Bacteria will move in like squatters. Scavengers will take what they can. Rain, heat, pressure, and there'll be nothing left but perhaps a few fragments of bone in whatever's left of your coffin. That's not just your fate, that's the fate of almost everything that has ever lived. Billions of animals, billions of lives, entire worlds of creatures wiped clean like they were never here. The odds of becoming a fossil are astronomically small. Estimates suggest somewhere around 1 in several million for vertebrates. Even worse for soft-bodied creatures. The odds of becoming a well-preserved fossil, one that captures not just your bones but your skin, your last meal, maybe even the color of your hide. That's not a discovery. That's a glitch in reality, which makes the discoveries we're about to explore nothing short of miraculous. These aren't your typical, we found some teeth and part of a leg bone fossil announcements. These are prehistoric organisms preserved so exquisitely that they challenge our understanding of what's possible. Frozen moments that let us peer across millions of years with shocking clarity. In 2011, a heavy equipment operator named Sean Funk was working his shift at the Millennium Mine in Alberta, Canada, doing what he did every day, scooping up oil sand deposits with his excavator. Then his bucket hit something that definitely wasn't supposed to be there. What emerged from 110-million-year-old marine sediments was so well preserved that the paleontologists called in to examine. It initially thought they were looking at a statue. The creature, later identified as Borealopelta markmicheli, a type of nodosaur, wasn't just fossilized. It was mummified in stone, preserved in 3 dimensions with skin, armor plating, and internal organs still in their original positions. 18 feet of armored dinosaur, looking like it had died last week rather than during the early Cretaceous. The preservation captures details that normally vanish within hours of death. Individual scales are visible across the body surface. The bony armor plates, called osteoderms, remain in their original arrangement. No scattering, no disarticulation, just a complete suit of biological tank armor frozen in stone. Even the skin texture is preserved, revealing a pebbly surface between the larger armor plates. But here's where it gets truly exceptional. Scientists found melanin, actual pigment molecules, 110 million years old, that revealed this nodosaur was reddish-brown with a lighter underbelly. It's called countershading, darker on top, lighter below. A camouflage pattern used by modern animals, from deer to sharks to great white sharks. The fact that an 18-foot, 3,000-pound walking tank needed camouflage tells us something fascinating about Cretaceous predators. They were scary enough that even heavily armored prey needed to hide. The stomach contents were preserved too. Fern fragments, identifiable to specific species, giving us a snapshot of this nodosaur's last meal. Between the stomach contents and pollen found with the fossil, researchers reconstructed not just what it ate, but when, during late spring or early summer, based on the plant species present. The nodosaur likely died near a river, possibly during a flood. Its carcass was swept out to sea, where the bloated body eventually sank in deep, oxygen-poor water. Rapid burial in marine sediments, combined with specific chemical conditions, prevented decay and allowed mineralization to preserve even soft tissues. The body landed upside down, which is why the armor plating on its back is so spectacularly displayed. It's now one of the Royal Tyrrell Museum's most prized possessions, a 2,500-pound reminder that under the right conditions, extinction doesn't have to mean obscurity. Siberian permafrost is nature's deep freezer, and occasionally it yields discoveries that blur the line between paleontology and forensic pathology. In 2010, local residents near the Laptov Sea in Siberia discovered something remarkable: a mammoth so well preserved that calling it a fossil seems almost insulting to the concept. Yucca, as she came to be known, wasn't mineralized bone. She was frozen flesh, 39,000 to 40,000 years of it. The preservation is genuinely unsettling if you think about it too long. Muscle tissue retained its reddish color. The woolly fur, though matted and dirty, was still attached. The brain, arguably one of the most delicate organs, survived nearly intact. Scientists recovered what they believe is the oldest RNA ever found, pulled from muscle tissue that had been frozen since the late Pleistocene. Unlike the nodosaur's mineralization process, which replaces organic material with stone over millions of years, ice preservation is fundamentally different. It's suspended animation, not transformation. Cells remain cells. Proteins remain proteins. The mammoth that Yucca was when she died is, chemically speaking, largely the same mammoth that thawed out 40,000 years later. Hence why researchers could extract and sequence genetic material with relative ease. The level of preservation allowed scientists to do something unusual, perform what amounts to a forensic investigation. Yucca's twisted trunk and body position suggested a violent death. Examination revealed evidence consistent with predation, most likely a cave lion attack. Claw marks on the skin, tissue damage patterns, even the positioning of the carcass, all pointed toward a predator that took down a young mammoth and possibly fed before something scared it away. There's something darkly fascinating about being able to reconstruct the final hours of an animal that died when humans were still sharing the planet with them. Yucca was likely around 6 to 9 years old when she died. She'd been alive, walking around, eating vegetation, interacting with her herd. Then a cave lion, then permafrost, then 40,000 years of nothing, then confused Russian researchers trying to figure out why there was fresh blood in a mammoth. Actually, one correction to the record, Yucca was initially reported as female based on size, but later genetic analysis revealed the mammoth was actually male. Even with near-perfect preservation, apparently, sex determination isn't straightforward without DNA testing. The scientific value of ice-preserved specimens like Yucca can't be overstated. While mineralized fossils can tell us about structure and size, frozen specimens preserve soft tissue anatomy, parasites, gut bacteria, last meals, seasonal coat changes, details that would be impossible to determine from bones alone. Every frozen mammoth is a biological time capsule, packed with information about Pleistocene ecology, climate shifts, and what life was actually like in the Ice Age, down to the smallest details you'd normally never get to see. In 2012, paleontologists working in Liaoning Province, China, already famous for its exceptional fossil preservation, announced a discovery that fundamentally changed our understanding of tyrannosaurs. They'd found 3 individuals of a new species, Yutyrannus huali, and all 3 were covered in feathers. Not the kind of feathers you'd find on a modern bird. These were more primitive, filamentous structures called protofeathers, some reaching up to 20 centimeters long, but still, unambiguously, feathers. Now, feathered dinosaurs weren't exactly news by 2012. Liaoning Province had been producing spectacular feathered dinosaur fossils since the 1990s, completely revolutionizing how we visualize these animals. The problem was that most feathered dinosaurs were small, chicken-sized, turkey-sized at most. Easy to imagine them with fuzzy coatings because, well, many modern birds are small and fluffy. Yutyrannus was not small. The adult specimen stretched 30 feet from snout to tail and weighed an estimated 3,000 pounds, and it was covered in long, shaggy feathers. Suddenly, the idea that large tyrannosaurs like T-Rex might have had feathers became much more plausible. If a 3-ton early tyrannosaur could support a feathered coat, who's to say larger species couldn't? The preservation quality of these fossils is what makes them so valuable. Soft tissue preservation in Liaoning province occurs through a specific process involving volcanic ash that buried animals rapidly, sealing them in fine-grained sediment before decomposition could erase delicate structures. You can see individual feathers, sometimes with enough detail to determine their structure and arrangement. The feathers on Eutyrannus appear to have covered most of the body, though density probably varied by region. Thicker on the back and tail, possibly thinner on the legs. There's also the possibility that the feathers serve display purposes, attraction, intimidation, species recognition. Modern birds use feathers for thermoregulation and communication. No reason dinosaurs couldn't do both. The discovery sparked the inevitable debate. Tyrannosaurus rex, feathered or scaled? The evidence remains mixed. Close relatives from cooler climates show feathers. Skin impressions from large tyrannosaurs show scales. Current consensus leans toward T. rex, having some feathers, possibly on the back and tail, with scales on other regions. It might have varied by age. Juveniles feathered for warmth, adults losing the coat as they got larger, and their internal heat production increased. But Eutyrannus removes any doubt. You can be a multi-ton apex predator and still rock a feathered look. The Cretaceous was apparently more diverse in its fashion choices than we gave it credit for. Sometimes a fossil tells a story so clear, so dramatic, that you don't need a paleontology degree to understand exactly what happened. You just need to look. In 1952, legendary fossil hunter George F. Sternberg was working in the Niobrara chalk formation of western Kansas when he uncovered something spectacular, a 13 to 14 foot Xiphactinus audax, one of the most fearsome predatory fish of the late Cretaceous. These animals were the terror of ancient seas, equipped with massive jaws and teeth like daggers, fast enough to run down prey in open water. This particular Xiphactinus had a 6-foot Gillicus arcuatus inside it, completely intact, undigested, still perfectly articulated inside the larger fish's body cavity. The fish within a fish fossil is now one of the most famous specimens in paleontology, currently housed at the Sternberg Museum of Natural History in Kansas. Photographs of it appear in textbooks, documentaries, museum displays worldwide. It's the poster child for death by overambition. Here's what appears to have happened. Xiphactinus, being an apex predator accustomed to eating whatever it wanted, attacked and swallowed a Gillicus that was a bit too large for comfort. Gillicus was no small prey fish. 6 feet is substantial, with a robust body and its own set of teeth. The Xiphactinus managed to get it down head first, but that's where the success story ended. The prey fish likely thrashed around inside the predator's gut, possibly rupturing internal organs or causing trauma that led to the Xiphactinus's death. Death came quickly enough that decomposition didn't scatter the bones. Both fish sank to the seafloor, were buried in fine chalk sediments, and mineralized together in their final, unfortunate configuration. What makes this fossil exceptional is the preservation of both predator and prey in their death arrangement. You can see every bone of the Gillicus still in anatomical position inside the larger fish. Scales are preserved, fin raise, even the positioning tells a story. The prey fish is oriented head first, the way a predatory fish would swallow large prey to avoid the spines catching in its throat. The western interior seaway, where these fish lived and died, was a chalk-forming environment with conditions that favored exceptional preservation. Low oxygen levels at depth prevented scavenging and slowed decomposition. Fine-grained sediments buried carcasses without disarticulating them. The result is a fossil record that captures moments rather than just accumulated bones. There's dark comedy in this fossil. Here's an apex predator, something that spent its life terrorizing everything smaller than itself, ultimately done in by its own appetite. The prey fish gets the last laugh, Sort of. They both died, but at least the Gillicus took its killer with it. In 2015, in the Badlands of Wyoming, researchers made a discovery that would become the paleontological equivalent of hitting the jackpot: a nearly complete Allosaurus skeleton, preserved in exceptional condition with almost no scavenging, minimal weathering, and even patches of fossilized skin. They named him Big Joe, though the scientific designation is Allosaurus jimmadseni, a species formerly described only in 2020, partly based on this extraordinary specimen. At 95% complete, Big Joe represents the best preserved Allosaurus ever found, and one of the most complete large theropod skeletons in existence. 30 feet from nose to tail, around 4,000 pounds in life, approximately 30 years old at death, practically ancient for a large predator, suggesting this individual was either very good at its job or very lucky for most of its life. The completeness alone would make this fossil remarkable. Most dinosaur skeletons you see in museums are composites, bones from multiple individuals assembled to create a single display. You might have the skull from one animal, legs from another, vertebrae from a third. It's paleontological Frankensteining, and it's standard practice because finding one individual with all its parts is vanishingly rare. Big Joe is different. With 95% of the skeleton present, researchers could study individual variation, pathology, growth patterns, things impossible when you're working with composite specimens. The bones show evidence of healed injuries, suggesting this Allosaurus survived multiple encounters with prey or competitors. Ribs that had been broken and healed, evidence of infections that were fought off successfully. This wasn't a pristine, theoretical dinosaur. This was a specific individual with a life history written in bone. But the real treasure is the skin impressions. Fossilized skin is incredibly rare in dinosaurs because skin decays so quickly. For it to preserve, burial has to be essentially immediate, and conditions have to be exactly right. Big Joe has patches of fossilized skin showing the texture and scale pattern. Small, snake-like scales across the body, not the massive crocodilian plates popular in older reconstructions. The specimen is currently housed at the Museum of Evolution in Knuthenborg, Denmark, where it's been meticulously prepared and studied. The preparation process alone took years. Removing the surrounding rock matrix without damaging delicate bones is painstaking work, requiring tools ranging from industrial rock saws to dental picks and air scribes. The specimen helps answer a fundamental question in paleontology: how much variation existed within a species? When you're working with fragments from multiple individuals, separating individual variation from species-level traits is extremely difficult. With Big Joe, researchers have a baseline. This is what one specific Allosaurus jimmadseni looked like, in detail, at approximately 30 years of age. In 1971, a Polish-Mongolian paleontological expedition working in the Gobi Desert of Mongolia uncovered something that looked like a snapshot from a Cretaceous death match. Two dinosaurs, predator and prey, locked together in combat. Not scattered bones that might have accumulated together by chance. Not a predator found near a prey skeleton with ambiguous positioning. This was unambiguous. Velociraptor mongoliensis, with its infamous sickle claw, embedded in the throat of Protoceratops and Druzy, while the Protoceratops had the Velociraptor's arm clamped in its beak. They'd been killing each other when something killed them both. The fossil, now known simply as the fighting dinosaurs, is considered a national treasure of Mongolia and is one of the most dramatic specimens in the entire fossil record. Both skeletons are nearly complete and fully articulated. Every bone in place. No scattering, no disarticulation. The positioning is so clear that you can reconstruct the fight sequence just by examining the fossil. The fight appears to have unfolded like this. Velociraptor attacked, probably ambushing from cover. It got its sickle claw into the Protoceratops's throat area, likely aiming for the jugular or attempting to pin the herbivore down. Protoceratops, in a move that probably surprised the predator, managed to clamp down on the Velociraptor's arm with enough force to trap it. Neither could disengage. Then something catastrophic happened. The leading theory is a collapsing sand dune. The Gobi Desert, 75 million years ago, was still a desert, with shifting dunes and unstable sediments. A dune collapse or sandstorm could have buried both animals alive in seconds, too quickly for either to escape. Alternative theories suggest a flash flood, though the preservation is more consistent with dry burial. What's certain is that death came fast enough that both animals remained in fighting position. No scavengers scattered the bones. No weathering pulled the skeletons apart. They were buried together, locked in mutual destruction, and stayed that way for 75 million years. The fossils spent years traveling in exhibitions before Mongolia tightened restrictions on national treasures leaving the country. There was even a legal battle in the 2000s when a different Protoceratops skull was about to be auctioned. Mongolia successfully argued that fossils found in Mongolia belong to Mongolia, regardless of who dug them up. The fighting dinosaurs themselves never left the country again after returning from exhibition. What makes this specimen unique isn't just the preservation, but what it reveals about behavior. This is direct evidence of predator-prey interaction, frozen mid-event. It confirms that Velociraptor used its sickle claw as a gripping weapon. It shows Protoceratops was capable of defending itself effectively. It proves these animals interacted exactly as reconstruction suggested they might. In 1987, researchers working in the Pierre Shale Formation of Kansas made a discovery that would settle a long-standing debate about marine reptile reproduction. A Polycotylus latipinus, a type of plesiosaur with a fetus inside. Not eggs, not egg fragments. An actual developing fetus still inside the body cavity, preserved in position. This 15.4-foot adult plesiosaur had been pregnant when she died, carrying a single offspring that measured about 5 feet long, roughly 1/3 the mother's length. The fetal bones showed characteristics consistent with late-stage development. They weren't fully ossified yet, showing the unfused state typical of pre-birth or very young individuals. The discovery was revolutionary because it provided the first direct evidence that plesiosaurs gave live birth rather than laying eggs. This might not seem like a huge revelation. Plenty of marine reptiles give live birth today, from sea snakes to some sharks. But plesiosaurs weren't related to modern marine reptiles. They were their own experiment, and how they reproduced had been pure speculation. What's particularly interesting is the single offspring strategy. Most reptiles, whether egg layers or live bearers, tend toward multiple offspring. Sea turtles lay dozens to hundreds of eggs. Sea snakes can give birth to 10 to 20 young at once. But this plesiosaur appears to have been gestating a single, relatively large offspring. That reproductive strategy is significant because it's associated with parental care. Animals that produce many offspring typically provide little to no parental investment after birth. It's a numbers game where most offspring die, but sheer quantity ensures some survive. Single offspring or very small litters suggest the opposite. Fewer offspring, but more investment in each one's survival through protection, feeding, or teaching. Modern animals with similar strategies include dolphins, whales, elephants, species that show extended parental care and complex social behavior. The implication is that plesiosaurs might have exhibited similar behaviors, with mothers protecting and possibly feeding their young for extended periods after birth. The fossil itself is beautifully preserved, with both mother and fetus clearly visible. You can identify individual vertebrae in the fetal skeleton, see the position of the limb bones, even observed the size differential between adult and fetal elements. The fetus appears to have been positioned head first, consistent with typical live birth orientation in modern animals. Consider what had to happen for any of these specimens to exist. First, the organism had to die in exactly the right place, not too exposed, not too deep, with the right sediment type and chemistry. Then burial had to happen quickly, before scavengers scattered the bones or decomposition erased soft tissues. Then geological processes had to be gentle enough not to crush, fold, or melt the remains over millions of years. Then erosion had to expose the fossil at exactly the right moment. Too early, and it weathers away. Too late, and it remains buried forever. Then, someone had to be looking in exactly the right spot, at exactly the right time. Every fossil is a miracle of chance stacked on chance. These discoveries represent the success stories, the winner of nature's cruel lottery, where the prize is immortality and the cost of entry is death. They're messages from a world that wanted to be remembered, preserved by physics and chemistry, and luck in quantities that shouldn't be possible, but somehow happened anyway. But not every fossil tells a peaceful story. Some preserved the exact second everything went wrong. If you're ready for the darkest examples of that, click on our next video. This is Roaring Echo. Bye for now.